it is important that we take time to learn about the 6 degrees of freedom. Our part must be fully constrained for our alignment to be correct. If our part is not fully constrained, our values may be suspect, as the alignment is permitted to rotate freely in one axis. Another instance might be, for example, our x-axis origin might come from the home position because we failed to constrain this translation. This might better help you visualize what is happening. Every part must have these degrees of freedom constrained. Let's create a simple 3, 2, 1 alignment. Please understand that 3, 2, 1 does not mean 3 points on a plane, 2 on a line, and 1 point. It describes the degrees of freedom that are constrained with each feature. When you probe the plane, the part is leveled, constraining 2 rotational degrees of freedom and 1 translational. The part is fixed to the surface plate and can no longer rotate about the x or y axis. The origin is placed on the plane and the part can no longer move up and down along the z-axis. The plane will be leveled to the CMM table. This will constrain 2 rotational constraints, and setting z origin on this plane will constrain 1 transitional constraint. That is 3 constraints. This line will align the part to the x-axis, and constrain the last rotational constraint around the z-axis. The y-origin is set to this feature, constraining 1 transitional constraint. This is 2 constraints. Measuring the point, and setting this as an origin, will constrain the last degree of freedom, the translation along the x-axis. Click OK to accept the alignment.